Hello everyone, Dr. Alex Agrawal taking your course ME 404 Fluid Mechanics. So in last class we have seen the introduction part of compressible flow. This class we will see the velocity of sound and pressure wave inside the fluid medium, and we will see the very important thing, that is Mach number. Okay, so let us start with velocity of sound and pressure wave in a fluid medium. So why something get transmitted from one point to another? Because of the disturbance. The disturbance in solid, liquid, and gas is responsible for transmission from one point to another, and the velocity with which this disturbance is transmitted is depends upon the distance between the molecules of the medium. So, in case of solid, the molecules are very close to each other, so the disturbance will move or transmit very fast. But in case of liquid or gas, the distance between the molecules are relatively greater, and because of this the disturbance from one point to another point will take some time before it transmits. So the maximum distance is for fluid. The distance between the molecules is maximum for fluid, and hence the disturbance will take maximum time to travel from one point to another in case of fluid, and that is for gas, because in gas the distance between the molecules is maximum as compared to liquid. Okay, so this velocity of disturbance is depend upon the distance between the molecules. Okay, and on which factor the distance between the molecule is dependent? It depends on the density, because if the solid has high density, and because of that high density the molecules are very close to each other, and because of that the disturbance transmit fast. But in case of gases, the density is relatively low, very low, and because of that the distance between the molecule is higher, and because of that the disturbance transmission take more time. So if we increase the density of the fluid, or if we increase the density of the gas by compressing it, what will happen? It will density will increase, and because of this increase in density, because of the density increases, because we are applying pressure, we are applying force, the molecules distance between the molecules get reduces, and transmission of disturbance start taking place quite quickly. Okay, so ultimately the velocity of sound or pressure wave in fluid depends upon the pressure and density. Hence the velocity of disturbance depend upon the change in pressure and density of the fluid, and on the basis of that there is a formula of that velocity of sound, that is given by under root dp by d rho. Dp is change in pressure and d rho is change in density. Okay, so this above equation gives the velocity of sound wave. Okay, and now there are various other formula depends upon other thing. This formula can be written in different ways, like if you want to represent that formula in terms of bulk modulus, so in terms of bulk modulus, the velocity of sound is under root k by p. In case of isothermal process, suppose the process is isothermal and we have to know the velocity of sound in that isothermal process, then the formula of sound is given by under root rt, whereas velocity of sound for adiabatic process, it is given by krt. You know that what is r and what is k, so I don't have to tell you again. So these are the three formulas that are very important, but remember which formula is to use where. If it is given that the process is isothermal in the numerical, then only you will going to use this formula. Okay, second formula. Otherwise you have to take this formula, that is c is equal to under root k by rt. We have to consider the process to be adiabatic until and unless it is not given that the process is isothermal. So generally we will use these two formula for calculating the velocity of sound. Okay, now let us move to the Mach number. That is very important thing for compressible flow. Okay, so what is Mach number? Mach number is defined as the square root of the ratio of the inertia force of flowing fluid to the elastic force. Okay, and therefore Mach number can be written as under root of inertia force by elastic force. Inertia force is given by rho into a into b square, that we have already seen. Elastic force is given by k into area. Now this area and area term will be cancelled out, and if you can keep this rho just below this k, so v square by k by rho. Now this v square can come out from the under root sign, and it can be v, and there will be under root k by rho, and this k by rho, under root k by rho, we have seen just here, where this k by rho, under root k by rho is velocity of sound. So this can be replaced by velocity of sound. So from here we can get Mach number as velocity of anything upon velocity of any object upon velocity of sound. So Mach number is given by this. So if a body is moving with certain velocity, we have to keep that velocity in numerator, and we have to keep the velocity of sound in that medium here, and we can calculate the Mach number. Okay, so this depends upon the medium also. So the Mach number can also be defined as the ratio of velocity of fluid or body moving in a fluid to the velocity of sound in that fluid, in that medium. Okay, so for compressible fluid flow, this Mach number is a non-dimensional parameter. How? Because here also there is a velocity, here also there is a velocity. This is velocity of body and this is velocity of sound. So the unit will be same, and this is a dimensionless number. And on the basis of Mach number, what we can get that the flowing fluid or the body which is moving, what type of flow it is. Okay, so it can be categorized as subsonic flow. Second one is sonic flow, and third one is supersonic. So let us see what is subsonic flow. A flow is said to be subsonic if the Mach number is less than 1. And now see, m is equal to v by c. How and when this Mach number will be less than 1? When the velocity of any body or flowing fluid is less than the velocity of sound, we will get Mach number less than 1. And when this happens, we can say that the type of flow is subsonic flow, where v is less than c. Okay. Now second one is sonic flow. Sonic flow is when Mach number is 1, and when it will take place, when the velocity of any body will be equal to the velocity of sound. So we will get Mach number 1. So when these both velocity are equal, we'll get sonic flow. Again, supersonic flow, which is very important in terms of jet plane or aeroplane moving, that velocity of body is greater than the velocity of sound and in that medium. So in that case, v is greater than c, so we'll get Mach number is greater than 1. And when the Mach number is greater than 1, we say that that flow is supersonic flow. So on the basis of this dimensionless number, we can get that whether the flow is subsonic, sonic, or supersonic flow. So this is about Mach number. In next lecture, we will see few numericals related to the Mach number. Thank you for now.